Today we're going to look at solving systems of equations through graphing. So we have our two equations, and first thing, they are both in slope-intercept form, so that's where we want to start. I'm going to graph my first equation, and remember we always start at the y-intercept. So my y-intercept is a positive 1, so I'm going to put my first dot right here at 0, positive 1. Now I use my slope, which is my coefficient to x, to determine how I move that line. It's a positive 2, meaning it's going to be up 2 to the right 1. So I start at my positive 1 and I'm going to go up 2 over 1, up 2 over 1. And you can keep doing that to get however many points you want up there. Remember to do if you need some points down in this quadrant, instead of going up and to the right, you're going to go down 2 to the left, down 2 to the left. And then with as straight a line as possible, you're going to connect those dots. I'm going to label that a 1, so we know that was equation number 1. Now to do my second one, my y-intercept is a positive 7. So I'm going to start right here at 7. So I'm going to go up 1, 2, 3, 4, 5, 6, 7. And here, my slope says negative x. That negative x is understood to be a negative 1 or negative 1 over 1. So from my plus 7, I'm going to be going down 1 to the right 1, down 1 to the right 1, down to the right, and you can keep going. If you want some points up here, then you go up and to the left, and we connect those. And we can see that those lines crossed or intersected at this point right here. So if I'm looking at what that point is, it looks like x was 2 because I went over 2, and then I went up 1, 2, 3, 4, 5. So y was a 5. And we can check that by just plugging in my x and y value into either equation or both equations. So let's say if y was 5, I'm going to use this one, and x is 2, will they be equal to each other? So instead of that x, I'm going to plug it in to be a 2. So 2 times 2 is 4. And yes, this side does give me a 5, so I checked it. We can plug it into our next equation also, and check that one as well. But for sake of time, I'll let you do that one. So you can pause it, you can plug in your x and y values for equation number 2 and make sure that it still works out with x equals 2 and y equals 5. So when you're solving systems by graphing, the point where they intersect or the point where they cross, that is the solution. There are some special cases where they never cross, like if you have a set of parallel lines, and if they never cross, then there's no solution. So let's try looking at this one. In this one, I'm going to start off where they are not both in slope-intercept form. So this one's in slope-intercept form. We're good to go on that one, but this one is not. So our goal is to get the y by itself, so I need to move this whole 2x. So I do that by doing the opposite or the inverse. So I'm going to subtract 2x from both sides, bring down my y. Now I cannot combine 1 and negative 2x, so I'm just going to write them in slope-intercept order. So negative 2x plus 1. Now both of my equations are in slope-intercept form, and I can start graphing. So we'll call this equation number 1. And on equation number 1, my y-intercept is going to be a negative 2. So I'm going to start my graph at negative 2. So down here, I'm going to go down to negative 2. And that's where I'm going to stop. This x, remember, that tells me that my slope is a 1 or 1 over 1. So from here, I'm going to go up 1 to the right 1, up 1 to the right 1. And you can keep doing that as often as you need. If you want some points over here, you go down 1 to the left. And then you make your line. And I'm going to put a 1 just so that we know that that's the equation that I just graphed. The next one, we're going to use our slope-intercept form. And that one, my y-intercept is a 1, so that's where I'm going to start at positive 1. And my slope is -2 or -2/1. So that tells me I need to go down 2 to the right 1, down 2 to the right 1. If I want some points up here, if we needed, so maybe this line was up here, then I could keep going up there. We can see that these 2 points, those 2 lines cross or intersect right there. The point that they intersect, I went over 1, so going side to side is my x value, and I went down 1, going down is my y value, so that would be at -1. So the ordered pair for that point, the ordered pair for where they intersected was 1, -1. So we can plug that in to check our equation. You can plug it into either equation, plug it into both would be great. So on here, when y is a -1 and x is 1. So if I said -1 is equal to 1 minus 2. Well, 1 minus 2 is -1. Yes, it worked out. Go ahead and pause the video and you can plug in your ordered pair into our next equation, or second equation, to see if it works out. So that's how you solve a system of equations through graphing. Remember that wherever they cross, wherever they intersect, that ordered pair, that x and y value, is your solution or your answer. There are special case scenarios, and you can look at the notes that are also linked on this lesson, where there are ones that won't cross, and that would be an example of parallel lines, because they will never get any closer or farther apart from each other. Thank you. I hope you guys are having a great week.